So right now we're looking at AP Calculus free response question, and this is a region problem, and it's an automatic indicator that it's a region problem when you see some sort of section, or you're looking for an area, you're revolving it, some sort of spinning, or if you have setting up cross sections where you're building like semicircles or something on it. Those are the typical questions that you'll end up seeing. So this one, obviously we have region R. This is 2019, problem number 5, so no calculator. And let's go ahead and try it. Let R be a region enclosed by the graph of, it looks like here we have one function. Okay, and that is a little scary in here with cosine. It looks like if we had to integrate, we would have to use some u substitution on that part. And the other function right here, which looks like a parabola. Looks like the parabola, because there's an x squared, the parabola is going to open down. Okay. The y-axis, the vertical line x is 2, so since that's the x-axis, graph it the other way, that's that line right there. That's that region, or the end of the region, as shown in the figure above. So first question, find the area R. So just find the area of this thing. Whenever I'm finding the area of something, I always go with the good old structure above minus below. Okay, and so we're going to integrate in that order, above minus below. And I think the first question I'm going to have is which is which? Is it this function, the parabola, or is that function? So if I'm looking at the parabola, it should be opening down. That means, oh, and also this thing looks like it's starting to curve back on itself, which wouldn't be a parabola, right? So this one's going to be the parabola. That is h of x. h of x. I'm going to label them so I don't forget. Don't accidentally mix them up. And it looks like this would be my cosine wave that would keep going back and forth. That one's going to be g. So we're going to integrate from here. We're going to slice this thing up. I'm not going to draw on it because I might have to use the picture for another problem. But start slicing it up like this, and it looks like I'm slicing it in the x direction, slicing up the x-axis. So way out here, I'm going to write dx. Okay? If it was a calculator question, I would just go ahead and write h of x minus g of x dx from whatever to whatever, and I would be integrating on a calculator from there. But since it is no calculator and I have to integrate this by hand, let's go ahead and try to figure it out. H is above, so I'm going to write that one first, and I'm going to have 6. Do I want to simplify this now, or do I want to simplify it later? I think I'm going to try to clean that up just a little bit. I'm going to have 6 times negative 2, and then multiply out x minus 1 times x minus 1, and that's going to be, let's see, x squared minus 2x plus 1. Okay, and now I'm subtracting all of g of x, which I could put in parentheses, but I think instead I'm going to put plus 2 and minus 3 cosine, running out of room, pi over 2x. And that's why I put that dx really far out, so I was hoping to be able to squeeze all that in now. All right, so I still just have a little bit more simplifying to do before I actually want to integrate this thing. Looks like that negative 2 is going to go to everything, so I'm going to integrate 6 and negative 2 times that, negative 2x plus 4x minus 2, and I still have plus 2 right there. And it looks like the negative 2 there and the positive 2 will end up canceling each other out. Minus 3 cosine pi over 2x dx. Okay, so what's gone? Looks like they were a little nice to me in terms of those two terms going away. Now I have to integrate this whole thing. Where to start? Well, I guess the easier part is over here. And this was supposed to be a negative 2x squared. Glad I caught that. All right, so integrating. Integration of 6, the antiderivative is 6x. Integrating this guy is going to be minus something. It's going to be x to the third divided by 3. So I'm going to put the 2 divided by 3. All right, this guy is going to be plus x squared, and that 4 is going to be divided by the 2, so that's going to be a 2. And now this guy is the part that's a little bit tougher. I think I'm actually going to do the u substitution, even though I think I might be able to guess what it would be. All right, so the u substitution, that's going to be u. Let me just write it right up here. U equals pi over 2x, and the derivative of u would be du over dx. And the derivative of this guy would be just the pi divided by 2. And that dx that's in the denominator here is going to get multiplied up to the numerator there. All right, so that doesn't have a pi over 2 in it, so I have to go ahead and switch that to the other side. That means it's going to be 2 divided by pi is going to be inserted into the problem. And that's not there anymore. Right, so dx is matching up with that thing, and it's going to get substituted in. This thing is matching up with u. The negative 3 I'm just going to ignore for right now. But let's see what we're going to end up with. We're going to end up with, and let me also write down sine, cosine, negative cosine. So the integral of cosine is going to be sine. So I'm going to end up with a sine, right, of this thing, which is pi over 2x. And now what is the coefficient out in front going to be? It's going to have the negative 3, and it's also going to multiply that 2 divided by pi. So it's going to be negative 6 divided by pi. Right, 3 times 2 is 6. So there we go. I still have to integrate, sorry, I've integrated. I still have to go ahead and plug in those numbers, those x values. Hopefully one of them is easier than the other. All right, so we have 2. 2 gets plugged in. It's going to give me 12. 2 here is 4, 8, 8, and that makes 16. So I have minus 16 thirds. 2 into this guy is going to be 4 times 2 plus 8. And now 2 in this thing. 2 divided by 2 is 1. So this is just pi. And sine pi, a sine wave is going to look like that, right? And pi is right in the middle. So that's going to be a y value of 0. So this whole thing is 0. And then times negative 6 over pi is 0. So I'm not going to write it down, but it would be plus or minus 0. All right, and now 0 plugged in. You do need to be quite a bit careful when you have sine or you have any sort of fancy function other than just a random polynomial with exponents. But 0 plugged in is going to make 0 there. 0 here is going to make 0. 2 times 0 squared is 0. And then sine of pi divided by 2 times 0, that's going to make 0. And sine of 0 is where it starts. So that's a y value of 0. So negative 6 divided by pi times 0 is plus 0 also. So the 0 was nice that they at least gave me that, since the problem has been, kind of tough so far. All right, I am going to clean this up just a little bit. So let's see, I could go ahead and combine some numbers first, then get thirds, I think. So here I have 12 plus 8, that's going to be 20 minus 16 thirds, and that's equal to, I guess I want to get all thirds. I guess be nice, that's going to be equal to something divided by 3 minus 16 thirds. And what number divided by 3? It's going to be 60. 60 minus 16, 44 thirds. Makes me a little nervous. 44 thirds is kind of a random answer. I wouldn't guess it would be too nice, but hopefully that ends up working out okay, and hopefully I got it right. That's kind of the scary part about the AP test, is when you get answers, you're hoping you didn't make some small mistake somewhere, right? Hopefully these other questions will go a little bit quicker. Region R is the base of a solid. Okay, so this is the bottom of a solid. And for the solid, at each x, the cross-section perpendicular to the x-axis has the area of that thing. So this is the area. Find the volume of the solid. They said perpendicular to the x-axis. So x-axis is this way. That means all our perpendiculars are going to be drawn in just like that, right? And we know the area. It's not semicircles. It's not squares. This is the area. Okay, since that is the area, that means that we have to integrate from something to something, from this guy, right? We're slicing it up this way, so we need to go from x is 0 all the way to x is 2, from 0 to 2. Okay, what next? I need the actual area, and this is the area. We don't have to set up with like something being squared, above minus below. This actually is the area, so we want to add up all of those areas. So we want 1 over x plus 3, and this is a dx since we were slicing up the x-axis. Dx. All right, so integrating this is a u substitution problem as well. It's real clean though. You can write it out, u equals x plus 3, but it's basically just going to be ln absolute value of x plus 3. and 0 and 2 still have to be plugged in. So ln of 5. And then I'm subtracting with a 0 plugged in. That's going to be ln of 3. And a lot of times they will rewrite things like this, especially if it's multiple choice, but I'm just going to leave it the way it is. But remember, if it was subtraction, I could rewrite it as division or something like that, right? ln of 5 divided by 3. I think that's pretty enough the way it is. All right, last part. Write but do not evaluate. Okay, that's good because I probably don't have too much more time on this problem, but write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the horizontal line y equals 6. Okay, so I'm supposed to, I always like to get a picture with these kind of problems. Y equals 6. The y-axis is here, so y equals 6 is 1, 2, 3, 4, 5, 6. Y equals 6 is right there. That means I would have this thing right there, and then it kind of does one of those deals. Is there some section in the middle? There might be. There definitely is missing section here, so it looks like I'm going to set up, I'm thinking a washer problem, and it goes up like that, and it kind of does it doesn't really matter at this point, but it does something like that. Okay. All right, so we have the bigger circles, which look like that. Bigger circles in there, and it's nice to draw those in every once in a while. Draw them in there so you could visualize what's going on. And it looks like the bigger circles, the radius is going to go from 6 all the way down to whatever that function is, which is g. Thank goodness I don't have to actually integrate that. But I have 6 minus g is going to be the above minus below, right? 6 is the top and g is the bottom. So I'm going to say integrate from something to something. I know this is a dx problem since we're slicing up the x-axis. So let me throw the dx way out here. dx, okay? I am going to go pi r squared since we're talking about circles, and like I said, it's going to be 6 minus g. So I have 6 minus g of x as my radius, and that's a pi r squared. Pi r squared. 6 minus g is my radius, and then I just circled it. All right, so the second part that I need to take away is going to be minus some other radius that is squared. Okay? And the other radius, like I said, it's nice to draw them in there. Draw the circles in there. Looks like all those circles is what I want to remove, and the radius on it is going to be 6 minus this function, which nicely I labeled as h. 6 minus h. 6 minus h. And maybe, you know, at this point in the test, maybe you're too tired, but it is nice to write 6 minus g of x and then 6 minus h of x. I would think that this would get full credit, but your notation is important. Sometimes it's nicer, I think, when you're just naming functions as g rather than g of x. So I'm going to leave it like that. Make sure you put your dx on there. Make sure you have your pi r squared, and also make sure you have your limits, which are from x is 0 all the way to x is 2. 0 to 2. All right, you're going to have another one coming at you. I think they didn't do one in 2018, even though I love these problems. They're nice, they're visual, they're kind of fun to do if it weren't an actual test worth points. I think they're kind of fun. But good luck on the next one, and hopefully this one helped you out.